In this video, we'll go through the calculation of center of mass for point masses, and we'll go through the formulas and also the calculations of this example question. So let's first look at the question. We have 3 point masses. They're placed in a 2D coordinate system. Their locations in meters are listed below with their masses. And the question is to find the center mass of 3 point masses. So we have these masses, 1.5, 0.8, 2.4, and we also have their coordinates. So 0.5, 1.2, negative 0.4, 1.4, and then these positions. So first of all, the center mass formula. So x center mass is this summation running through all masses, and mi xi, this is the mass and its corresponding x coordinate multiplied together. And then the bottom is the summation of all masses, mi, so this is the total mass. And if this is confusing to you, so we wrote it this way. So for 3 masses, the top summation gives you m1 x1, right, and m2 x2, m3 x3. So all the 3 terms are added together, masses and their corresponding x coordinates. And then the bottom summation is always the total mass, 3 masses. So the y center mass is very similar except for this y coordinate multiplied to the m, the mass. So we have y center mass equals m1y1 plus m2y2 plus m3y3, and then divided by the total mass. So if you have another coordinate such as a z, then it'll just say the same thing except that the coordinates will be z1, z2, and z3. And also, if we have more masses, we'll simply expand our expression. Here we'll have another mass with its corresponding y-axis, another mass with its corresponding x-axis, and then we'll also add that mass to the bottom to make the new total mass. So that's the formula. And let's take a look at these masses. So m1 is at 0.5 minus 2.1. So 0.5 is right here, minus 2. So minus 2 and a quarter, 2 and 1, and 1/8 right here. So we're roughly looking at this point here. And this is m1. And it's 1.5 kilograms. And then m2 is minus 1.2 and 1.7. So minus 1. Here's 1.25. So roughly here minus 1.2. And then positive 1.7. So 1.75. So roughly here 1.7. And I have a ruler here. So let me find that position. So it's roughly here. Okay. So this is m2.8 kilograms. And then m3 is 1.4 and minus 2.5. So 1.4, this is roughly 1.4, and minus 2.5 is this right here. So this line here. So we're looking at this point here. Let's get rid of that. Let's put dot here. So m3 is equal to 2.4 kilograms. So let's take a look here, just to have an idea where the center mass might be. So we know that the majority of the mass is here in the 4th quadrant, and these masses also have the mass majority of the total mass, right? 1.5, 2, 2.4, and here we have only 0.8. So we know that the center mass should be closer to the heavier mass side. So we know that the center mass is probably in this region. So let's draw maybe a blob right here. So the center mass is probably in this region after our calculation. Okay, so let's carry out the calculation here. So we'll just write on this line. So m1 x1, m2 x2, m3 x3. So 1.5, x1 is 0.5, m2 is 0.8, and okay, so x2 is minus 1.2, and m3 is 2.4, and x3 is 1.4, and we'll divide that by the total mass. So 1.5 plus 0.8 plus 2.4. Alright, so for the y center of mass, we'll do the same thing. Let's draw this fraction out. Roughly this long. Alright, so let's make sure we have the corresponding y coordinates. So my coordinate y is minus 2.1, and m2, this coordinate is 1.7. Okay, so and m3 is 2.4, and the y coordinate is minus 2.5, and the sum of the mass is same. Okay, so if we pause here and you can pull out your calculator, or maybe using some other software such as Python, or maybe a spreadsheet program to calculate the answers. So then we'll get the answers right away. So we're back. Hopefully you got your calculations correct. And keeping 2 decimals, we have the x center mass is 0.67, and the unit is meters, and the y center mass is minus 1.66, and the unit also is meters. Okay, so let's put this set of xy coordinates in our system. So 67, alright, so that's about 2/3. So it's roughly here, and 1.67, so 1, and then about 2/3. This is 3/2, no, 3/4, so 2/3 less than that. So we have approximately, oh, look at that. My guess was not too far off. Good thing I drew a large blob. So that's where the center mass is for this question. Thank you.